Hello everyone, this is Ali from OpenQP team. I hope you're doing well. This is the second part of Hartree-Fock calculations. We'll take a look at log files, log file structure in this part. Just to remind you, we did some RHF Hartree-Fock calculation, energy calculation for energy and gradient, and this was the input. And for, of course, for gradient, it was for gradient. It's only have this properties part, and the run type is grade. And here is energy. We can also add save mol in guest section to save a new JSON file. And when we do calculation, we can get we can get a JSON file, a log file, a Molden file, which you can use this one for visualizing your molecular orbitals, your system and different properties. And for JSON, it saves the molecular orbital information, other informations. You can use it for different purposes. We will talk about this later. So let's take a look at the log file structure. Right. It starts with the general information about OpenQP and its developers. Then you can see the number of atoms and charges you have specified in this part. You can review the basis set you have chosen. This is important because in some cases, in OpenQP you can give customized basis set, or you can edit some parts and give your basis set in JSON format. So it is important sometimes to check if it matches with what you have, what you gave it or not. You can see your geometry, the geometry you gave to OpenQP here, and this part is for the guest types. We have asked for a file to be saved like in JSON format, so it says compute orbitals. And okay, here maybe this, because it's RHF, you only have alpha orbitals, so yeah, it says copied. For beta, they are same. Now the general information about the CF options you have specified, and in more detail here you can see some options are false, you didn't specify them, and what are the default values for each keyword. After that, direct CF iterations began. You can see how the difference in energy will change with each iteration, and at the end you can see final energy after your SCF. Then molecular orbital and energies are here. Again, this is RHF, so we have only alpha orbitals, and these values, these numbers, are molecular orbitals from core to virtual, and these values are the molecular orbital energies in Hartree. And of course here is linear combination of atomic orbitals. After that, the energy components section contains the information about your energy, like 1 electron integral, 2 electron integral, and nuclear repulsion, which will give you total energy like here. You can find the potential energies in this part, but most of the time people only need this one. After that, OpenQP tries to see if you have applied any dispersion correction, which we didn't. And at the end it will give you final energy in this format. Because it is Hartree-Fock, it's only ground state. In our case, no dispersion applied, so the energies are the same here. This is important for OpenQP because sometimes you ask for lots of states in, for example, a spin flip or MRSF calculations. There will be lots of transitions and lots of other things, and you might only need the energy of the states you asked. So you can find them here apart from all of the other things. After this, there is some small properties information like electronic moment analysis and molecule population. And this is it. For energy, it finishes right here. And for gradient, it is somehow quite the same, but with some more parts. So again, some general information, your basis set information, the geometry you gave, the guess options you specified, SCF options and their default values, the iterations, molecular orbitals, the total energy. And from this part, you enter gradient calculation. Gradient of root 0. This is Hartree-Fock TD. I'm sorry, not TD. This is not time dependent Hartree-Fock. This is just Hartree-Fock. And so this is from root 0. You can find your gradient here. And the maximum gradient, which most of the time we only need this part. After this, again, we have some properties. But at the end, you can see the final energies, all right, and the final gradient. This is like exactly this part, but here you only have one state, one root, root 0. So you will see only one. In some cases, you will see the final one or some of them. And if there is any correction, DFT correction, dispersion correction, applied, you can see here, but we didn't apply anything. So this also is the format of log file for gradient. Unfortunately, in our wiki we don't have Hartree-Fock example because it was so simple and you can find it in examples. But if you want to check other calculations in details and some techniques, you can check our wiki page. Let me start from beginning. So you go to our GitHub, wiki, user guide, example input files, and for example in DFT you will see an example of input and explanation for each one of the keywords existing in this input. So that's it. I hope it was useful for you and see you in the next video.